All right, welcome to another PSL demo day. I'm Jason DeBacker. I'm an associate professor of economics at the University of South Carolina and president of the PSL Foundation. Today's demo day will be given by me. I'm going to talk a bit about unit testing, why it's important, why it's recommended in the PSL catalog criteria, and then show an example of unit testing in R, which is a little less straightforward than in Python. So I'll give a kind of rundown on how to do that. And I'm going to follow this demo day up with a blog post that'll give a few more details on unit testing in Python as well. All right, so let me share some slides here. All right, so I'm going to talk about unit testing for open source projects, given application in R. All right, so first of all, what is unit testing? Unit testing is about testing each individual unit or function of your software application. So in this case, what we're thinking about is breaking our software into its smallest testable parts and testing each of those parts individually. So this differs from kind of testing the output of your software in total. Here you're trying to break up and identify each specific kind of block or unit of code, whether that's working as expected. All right, so a little bit different than what might be called regression testing or testing the full kind of output of your model. That's important, but it's a little bit different than unit testing, and I'm going to focus on unit testing today. All right, so why would we want to write unit tests? So first of all, unit tests are important to ensure that your code does what you expect it to do. Right, that's important for anybody developing software, but it's especially important for those of us who are developing open source software, right? Because we want to encourage collaboration by the broader public, contributions from people in our, say, GitHub repository. And so if we're going to have people who maybe we're not familiar with, we don't know their background with our project, if they're going to be making contributions, we want to know that those contributions work as we think they do, right? And one way to do that is to write unit tests for your code. Another reason to do it is it's going to help you save time debugging, right? Writing these tests of each chunk of your code is going to help ensure that your code runs as expected, all right? And it'll be easier to find errors. Finally, writing these unit tests is going to help you better understand what your code is doing. Sometimes you think you have something in mind when you write a function, but when you put that kind of pen to paper, so to speak, or in this case, your keys or your hands to the keyboard, and you're writing that code, sometimes it might not come out just like you thought it would. And a unit test is, something else. You've got to go write this test to test that function. It's going to ensure that it's doing exactly what you thought it was going to do, all right? So those are the reasons to write unit tests. But a lot of people don't write unit tests, so there's got to be some drawbacks to doing, and there definitely are, right? So first of all, it takes time to write unit tests. Not only does it take time to write these tests, but sometimes it can be really tedious. You've got to go back over code you've already written, right? You can now execute your program. Why should I spend some time going back and writing additional code that doesn't add to the functionality, right? Why write these tests when I know I've got some output, right? So it can be time consuming and it can be tedious. You've got to go through these small chunks of code, thinking about what goes into a function and what comes out, and verifying that that's accurate. Right? So this is time consuming and tedious. And sometimes it's not just tedious, but it can require a high degree of cognitive capacity, right? It's hard to think about sometimes, how do I test this function in a way that's going to catch all the potential errors that could come about, all right? Now you can reduce that by kind of breaking your code into smaller chunks, right? And this is, good programming practices in general, but by writing smaller functions that, delineate different tasks in kind of very finite ways, you can reduce that cognitive burden, right? Because you're writing tests for just smaller bits of logic. But nonetheless, sometimes you can't do that, right? And there's a degree of cognitive capacity that's required. So it can be hard to think about, not just time consuming. All right. The policy simulation library and their catalog criteria requires unit tests of models, right? So we're coming down, the PSL Leadership Council, that is coming down on the side of, there are pros and cons to unit tests, but the pros outweigh the cons, right? Because we think for these open source projects and for projects that we want to be accurate and replicable, they need to have some degree of testing. And so part of the mandatory criteria to be listed in the PSL catalog is to have some unit tests of your code, right? We also require at least one test that generates key outputs from your material, and verifies that the model can reproduce those on anybody's machine, right? And so that's kind of more like a regression test. So we're requiring some unit testing and then at least one regression test, a test of the final outputs of the model, okay? So we think it's important. I'm going to show how to do it. And by doing this, I'm going to use an application here of a model that's a PSL incubating model. And it's very close to meeting the criteria for the catalog. In fact, I think they've checked off all the mandatory criteria now, and it's just up to the Leadership Council to talk about this model. And this is the Tax Foundation's capital cost recovery model. Right, this is a model of kind of essentially costs of capital for different investments. It's written in R. The model is in a single R script. It's not in an R package. So I'm going to show you how to test this, some of the functions in this script. But if this were an R package, the testing would work similarly, right? I'm going to use this as an example because something I've noticed in different open source repositories is that, you know, Python has a very user-friendly unit testing package called PyTest. And so I see many models written in Python having those unit tests available. Whereas when I look at different models that are written in the R language, I'm seeing much less unit test coverage or even any unit tests at all. And so I want to use this as an example because I think perhaps that's most helpful to show how to do unit testing in R. But I will follow this demonstration up with a blog post that I'll cover this example as well as provide information and examples on how to do this in Python. All right. So with that, I'm going to jump to sharing a different application here. Let me show you some code from this capital cost recovery model. Okay, so this capital cost recovery model, as I said, it's all in one R script. It's called capitalcostrecovery.r, and I've got the source code for it up here. Okay, so everything is in this one script, and essentially what this project is doing, it's reading in some data for different countries on their capital cost recovery methods, and then it's computing for various types of assets what essentially the cost of capital and effective tax rates look like across country. All right, so it's reading in some data, it's applying some functions to that data to compute some outputs that are important to this model. All right, so we've got some reading in of data, and then there's several functions defined here. All right, these functions happen to represent different capital cost recovery methods. But what we're going to want to do, these functions represent kind of those units in the code, kind of the smallest testable units. So what we want to do with this model, right, is we want to write code that tests these specific functions. Those will be our unit tests. I'm going to also demonstrate or show you how we've developed a test of the overall output of this model, kind of a regression test, something else that's required by the PSL catalog, right? So the first thing to know about R, and the first thing you'll want to kind of read up on when you are writing unit tests in R is a package called test that. That test that package seems to be the leading package for doing unit tests in R. And it's relatively straightforward to use, but you'll want to kind of look into the documentation for that package. That's what I'm going to use here, okay? So you can see in addition to this capital cost recovery.r script, I've got up 3 other scripts, all right? So let me go to kind of the smallest chunk that we can find. So I've got a script called test capital cost recovery.r. And this is going to this script is going to have unit tests of the different functions within that capital cost recovery.r. All right. In fact, I've only got 2 functions here tested. One is the SL function, and the other is the DB function. All right. So there are a few more functions. So this project doesn't have kind of complete coverage of, you know, there aren't unit tests for each function in their main script, but we've got unit tests for a couple of the functions, and I'll kind of walk through how those work. All right. So we're going to be using the test that function, our package, and kind of the main function there is test underscore that. All right. So test underscore that is going to define a specific unit test. All right. Inside the function arguments here, we've got a string, and that string is going to give the name of this specific unit test. So here it's just called test SL because it's going to test the SL function. right? You might have more descriptive names, like maybe we test the SL function with different configurations of input. Here we're just testing the SL function with one set of inputs, right? The second argument that we're going to have in this test that function is we're going to have our kind of assertion statement, the thing that we're trying to make true here in order to pass the test, all right? So here what I'm doing is I'm using this expect equal function in R. This is in kind of the base R library. And this expect equal function takes two arguments. And here I'm passing as the first argument, the SL function with specific input values to that SL function. And then the second argument in the expect equal function is what I expect to get out of that SL function with those inputs, right? So for this example, what we're doing is we're passing an input of 0.2 and 0.12 into the SL function. And if I do that, I expect to get back 0.807, okay? So how do I kind of know what I'm putting into this expect equal argument? So first of all, when I call this SL function, right, it has to correspond to how this SL function is written, right? And I can see that this SL function, looking at capital cost recovery.R, takes two arguments. It takes a rate and I, which in this case is an interest rate, all right? So there's a rate of capital cost recovery and then an interest rate that it's taking in, okay? And so when I test that function, I'm passing it those two arguments, in this case, specific values for those two arguments, okay? Right, so we're calling that SL function, passing the arguments just as it's defined in capital cost recovery.R, and in that script we're writing the unit test for. This second argument in expect equal is what I expect the output to be, all right? And so how did I arrive at this value? Well, what I did is I kind of looked at not just how this function is written, but in documentation for the capital cost recovery model. The authors of this project have very detailed explanations and equations defining what these functions are representing. So in this case, this is the straight line depreciation method, and they have an equation defining how that straight line depreciation method is determined. Okay, so what I did is I just set up a spreadsheet, and I essentially kind of by hand in that spreadsheet, I set up a function to represent their equations in their documentation. And then I passed in values for the rate of recovery rate and the interest rate to this function. And from my spreadsheet, the value I arrived at is 0.80746 and so on. Okay, and so I've computed by hand, not through the code. So I'm kind of double checking that their function works as they have written in their documentation, all right? And this test that function is going to fail if the straight line depreciation function doesn't return the value that I expect it to, all right? And I've done the same thing here for another function here, the DB function, all right? Okay, so that's step one in writing these unit tests in R is you have a script. You probably want to name the script with test something, okay? So start the name of the script with test, and this is an R script, so you want to have the extension .R. All right, other than that, you're just in this script, you're outlining different test that functions, which are going to represent tests of different functions in your code, or maybe multiple tests of a given function if you want to, if it's important to, say test different cases of this function or different input values. All right, so that's step one, is writing that test script with those specific unit tests in it, okay? The second thing you're going to need to do is you're going to need to write a script that's going to call those unit test functions, okay? All right, so this script I've called runtest.r, okay? And this runtest.r and the test capital cost recovery.r, notice that I've put them both in a directory called tests, okay? Right, that's going to help organize all the files we're using to test our project, our model here. All right, so I've got the test capital cost recovery.r and now this runtest.r script, both in the test directory, all right? So I'm importing two packages into this library, or excuse me, into this script. I'm importing the test that package and then the here package. The here package is just helping me essentially kind of define the directory I'm in and create relative paths so that this script will run on any machine. Okay. All right, so you can see there's, after that, just 3 non-comment lines in this code. So first of all, I'm going to find the directory where I'm at using that here package. Next, what I'm going to do is I'm going to call that capital cost recovery script. So this is going to be the source file that the subsequent tests are going to run on, right? So remember, I'm going to be writing unit tests for the functions in that capital cost recovery.r, all right? So I'm going to provide the path to that source file that we're testing here. All right, and then the final actionable line here in this script is just actually run the test, right? So, and how does that happen? Well, with the test that package, what I'm going to do is I'm just going to tell it what directory to look in for these test files, okay? So I'm going to say, look in that test directory. It's going to look in that test directory, and every R script in that directory is going to be run here with test that, okay? And I'm going to return the test results, all right? Which is going to give me a summary of how these tests performed, whether they passed or not, okay? All right, so with that, let me go to my R console and I'll show you how this is run. And we'll give an example where the test passed, and then we can change things and I'll show you what a failure looks like. All right, so we go to my R console. All right, and so I've already kind of put myself in this capital cost recovery directory. So that's my working directory here. So what I'm going to do to run these tests is I'm just going to call that run test.r script, that script we just looked at that had the 2 imports and then the 3 lines of code that are going to run our tests, okay? So I'm just going to run this file, okay? So I'm just doing source, path to the script. And if I hit return, it's going to run these tests, okay? So these tests require running that capital cost recovery model. It prints a little bit of output. And what the test that package does is it's going to report on our tests, all right? So I've showed you here 2 of the tests that in that capital cost recovery.r script, there were 2 tests, one of the straight line depreciation function and one of the declining balance depreciation function. All right, so those 2 tests, there's 2 dots representing those tests. So if we see those dots, that represents the tests passing, okay? There's actually another test script I wrote here, which is for testing the outputs of the capital cost recovery model. Okay, and there's several tests in that, and I'll go back and show you that. But let's focus on the capital cost recovery test here. So here we've got the 2 dots, each of those functions passed, okay? Let me go back to, just to show you what a failure looks like here. So if I were to report a different value here, so maybe 0.9 instead of the 0.807 being returned from that straight line depreciation function. I'll go back to R, and I'll run this test script again. And again, it's going to run that capital cost recovery model. It prints some output, and then we're going to get our output from the test that. Okay, and here we've got a failure. So it's making clear these tests failed, and it's describing where was the failure. Well, straight line calling that straight line function with arguments of 0.2 and 0.12 doesn't return something of 0.9. So there's something's coming back not as expected. All right, so that test failed. It's telling us what the difference are. All right. And so this is going to be a signal. We need to go back and maybe we need to double check our by hand calculation to make sure we're doing something right, or maybe there's an error in the code and it's not matching what, so maybe that straight line function wasn't written in the way that we were intending to write it. Okay. Right, so we'd kind of go back and look at our code and maybe update our values, right? And then we're going to come back and run those tests until we get those tests passing, okay? All right, So that's essentially it. Writing and running those unit tests are as simple as defining the unit test in a script and then having one more script that's going to call those unit tests by passing a test directory to the test stat package. All right, let me show you real quick here. Those other tests were a test of the outputs of the model. So this is testing that the kind of what's generated from the capital cost recovery model is being reproduced accurately on your machine. All right, so essentially this capital cost recovery model has a number of different outputs that are saved as CSV files. And so this repository has checked in to it all of these output files with the kind of file name expected. And so what this test does is it runs that capital cost recovery model for you, saves CSV files, and then checks that those CSV files match the expected files that are checked into the repository. So this is more like a unit test, but more like a regression test, but you can see it's set up in the same way, and it's called using the test stat package, just like the other tests are, because everything in this test directory is run, and this test output function or module is in that test directory. All right, and you can see in here, we are essentially writing test stat functions in a loop here because we're looping over the different files that we're checking. And essentially, we're reading those final outputs that are generated when the model is run, reading in the expected outputs, and then comparing the two, seeing that these two, in this case, data frames are equal to one another. All right, so there's an example here of doing the regression testing, which can be done with that test that package as well. All right, so that's it, right? For R, writing those unit tests, you'll want to look into the test that package. That's going to be kind of your primary package to do these unit tests. And from there, you'll want to think about how can I break my code up into those smallest testable parts and write functions to test each of those components of my code, right? Doing that's going to ensure that your code's accurate, and it's going to help you collaborate with others by making sure their contributions make sense with your model and produce accurate results, right? So look for a blog post to follow up with this and another demo day coming up in 2 weeks. Thanks a lot. Bye.